Hi pre-calc students, it's Miss Chaz again. This was the lesson that I jumped, well that was my chair, it's not me if you heard that. This is the lesson that I skipped because, well, it's all vocab and it's necessary information that you need to know, but yeah, not that whole, interesting or fun. So what I'm going to do is go through this. You should have the packet that I gave you in class so that you can copy notes on it. That is your only homework, is to watch this video and to take notes. We will worry about completing anything that we don't complete in this video next class and do some more practice on it. And then we'll kind of be doing the same things with radians. So exciting. All right, so the very first thing, and feel free to stop, and because I'm going to kind of go through this pretty quickly. If I can do this in one video, I'm going to try. I'm going to get 15 minutes about that on a YouTube video. So I'm going to move pretty fast. Just pause me if you need to and come back. All right, so um, trigonometry is the measure of triangles. That's really all it means. It's a Greek word, triangle measurement. That's where that comes from. Now you've seen some of the Greek letters that we've been using recently. Theta has been the one that we've used mostly so far. But these four are the four that we're going to see in our book and in the things you're going to see me doing. Alpha, beta, theta, and rho. These are the Greek letters they often use. There's 26 of them, just like our alphabet, but this is what they're going to be using, okay? All right, so the next thing is standard position. Standard position, as you can see, it's an angle that is in standard position has the vertex at the origin, so the vertex at the origin, right here, and the initial side on the positive x-axis. Okay, so make sure you get that definition down. A little side note, you'll hear me talking about central angles here and then. The central angles are angles that are in standard position. All right, so if I have an angle, ooh, don't judge me on my drawing. I'm sitting here at my dining room table on Monday. Yeah, that's right. Okay, so let's say we have our angle right here, and it's going to go from there, let's say out here. So this is a central angle that is in standard position. This is our initial side. I'm trying to change that, make that, there we go. This is our initial side. So we start with that. Over here is our terminal side, and I'm going to use these different axes to kind of label new things. Here's our terminal side. We should all know that this right here is our vertex. So we have an angle that is measured from the x-axis, I'm going to go like this, to the terminal side, and its origin is at the vertex. Sorry, the other way around. The vertex is at the origin. So I'm going to call this angle alpha. Okay, it's kind of like a halfway fish or something like that. All right, so that's the first thing. So if I continue, I can't put too much on any given one of these, I'm going to make another central angle here that is in standard position. We're going to end it in quadrant 1. So again, with the same kind of notation, we know that we have, here's our initial side, here's our terminal side, we have the vertex at the origin, quadrants, this is quadrant 1, just like when we're graphing any other time. Quadrant 2, quadrant 3, quadrant 4. Nothing is different about that. But we're going to be dealing with angles in degrees. That's what the title of this was in chapter 1. So we usually measure angles going counterclockwise. That's not 100% of the time, but we do. So this is a positive angle. The alpha over here is also a positive angle. So this would be 0 degrees. This would be our 90 degrees. This would be 180 degrees, 270 down here. And if we looped all the way around, this would now be 360 degrees. Okay? All right, so next, let's see what else I can add on to this. Let me draw another central angle. that is in standard position, but we're going to go the opposite direction. Okay? So here's our initial side, here's our terminal side, and this angle right here is considered to be, I'm going to say that this is alpha, and alpha is going to equal negative 90 degrees. So we're going clockwise. Okay, so that means that clockwise gives us negative angles. Clockwise, we get positive angles. Let's see if I can, there we go. We get positive angles. Back over here, we have counterclockwise. I just said that backwards, didn't I? All right, go back and change that. Counterclockwise, remember I can't talk and write. This gives you positive angles. And I'm going to go fix the other one. This one over here gives us negative angles. So let's make sure we fix that, everyone. Okay? So clockwise gives us negative angles. Counterclockwise gives us positive angles. Okay? Now I can also measure this twice. I can go either way. I can get this negative angle right here as negative 90 degrees, or I could go all the way around the other direction, and I could say that this is, I'm going to call it theta, a positive 270 degrees. They meet at the same position, okay, and they are technically the same exact angle measure. All right. The last one, I'm just going to throw in here one more. This is going to be, let's draw another central angle in vertex form. And here is the initial side. Here is the terminal side. If I go this direction, this is going to give me theta is 180 degrees. If I do the reverse direction, let me see what colors I can find here. If I go this direction, this is going to give me, I don't know, I can call it whatever I want, any letter I want, it doesn't matter. It's going to give us negative 180 degrees, okay? All right, so hopefully you have all that down. Again, welcome to pause and go back. Here we go, quadrantal angles. This is an angle in which the terminal side, that's the ending side, ends on an axis. So that very last example that we just did, and the one before it, the one that was negative 90 or 270, and the last one that was positive or negative 180 degrees, those were both considered to be quadrantal angles, okay? So sometimes you'll be asked to figure out what quadrant something falls in. So if you look at the questions at the bottom of your page right now, these are asking you to state the quadrant that it falls in. If it doesn't fall in a quadrant and it falls on an axis, that is called quadrantal, and we will write that, okay? All right, so I'm going to pick 3 problems to go over with you. I'm going to do number 1, I'm going to do number 7, and I'm going to do number 6, okay? And then, again, anything that we don't do here, you'll do in class next time, so don't fuss about that, okay? You don't have anything else extra to do. So problem number 1. I'm going to draw my axes, and I'm doing 50 degrees. So you should know 50 degrees is just going to fall into quadrant 1. Okay, so I'm going to draw my central angle in standard position. 50 degrees will be approximately right there. Okay, and we're going to label this. We're going to mark the direction that it's heading. That's what this is doing, marking the direction that it's heading. And we're going to write that this is 50 degrees landing in quadrant 1, because it did ask us to also state what quadrant the terminal side falls in. This is our terminal side. It's the end. Okay. All right, next one, number 7. Ooh, 820. How is that possible? Why in the world would there be 820 degrees? I want you to think about that. We'll talk about that next class. Why in the world would we need something that's 820 degrees? Okay, so let's talk about what the graph of it looks like. So we're going to draw the central angle, and we're going to figure out where it lands. Okay, so I don't have a calculator in front of me, but we want to use the 360. Let's see if I can grab one. We want to use the 360 degrees rotation to figure out how many times that is going to land. Hold on, I'm getting my calculator out. There it is. Okay, so if I take 820 and I subtract 360, I'm going to get 460, which means I'm still over one full rotation. Remember, one full rotation is 360 degrees. So if I subtract 360 again, I'm going to get 100 degrees. So I had to subtract 360 twice, which means I got to rotate around twice, and I'm going to end with 100 degrees. 100 degrees would fall over here. Here's 90. 100 is going to be, I don't know, maybe right there, right? So that's about where 100 would fall, but we have to mark that we had to rotate that many times. Okay, so remember I subtracted 360 twice. So I'm going to go around once, I'm going to go around twice, and then I'm going to land there. Okay, that little piece, last piece wasn't so great, but hopefully you get the idea. So you had to swirl around 2 times and then finally hit that angle measure right there. So this would be your 820 degrees and lands in quadrant 2. Okay? All right, and number 6. So number 6 is a negative angle, which means we have to go clockwise instead of counterclockwise to get that negative piece. And when you go counterclockwise, this is negative 90, this is negative 180, this is negative 270, and this was 0. But if I swoop back around again, this is going to give me negative 360 degrees. Okay, these are all degrees. I'm just being lazy. Okay, so we have our central angle that is measured in standard position. I've been on here for 11 minutes, so I only have a couple more minutes that I can spare, and then I'll have to make this 2 videos, okay? All right, so negative 280 then, if we go around, here's negative 270, so it's going to fall over here. So it's going to be, I don't know, maybe right there. You can see I'm very worried about the preciseness of where this is landing, okay? So our angle will go like this, okay? And this is going to be our negative 281 degrees, and we're going to land in quadrant 1. So we'll finish these next class, okay? You don't have to do the rest of them. Keep that in mind, all right? Okay, so I'm going to start with just the notes of this next piece and try to break these up as much as I can, and then I'm going to do, again, 2 different videos, okay? So Roman numeral 2 is coterminal angles. These are angles in which their initial and terminal sides are the same. Initial and terminal sides are the same, okay? So we're going to start with a central angle that is in standard position yet again, and I'm going to put it, let's say, here. Okay, it doesn't really matter what the measurement of it quite is at this point, but this angle right here, right? This is a positive angle going this direction. This, I'm going to call it alpha, let's say. And then we're going to have another one, which would be this angle right here. These are considered, they land in the same spot, the same position, so this is a coterminal angle. So if I call this one, let's say beta, beta is like a B, it's kind of got this long little thing going on here. We would find beta by doing whatever alpha is minus 360, and that would actually tell us what beta is, okay? Or we could do the other way around if we knew that one first. All right, so let's do another one. Here's another angle, the central angle in standard position. I'm looking to see what my notes say that I'm doing here, so give me a second, okay? All right, so I'm going to put one here. All right, now there's lots of different coterminal angles. That's one of the issues here, is there's an infinite number of coterminal angles. So when we get down to the examples, we'll talk about how we, get the same answers for things. So let's say I gave you alpha right here. Here's my alpha. I could have a coterminal angle going around the other direction, or I could have a coterminal angle that continues going around. So let's say I went like this and then I looped again. As long as I begin and end in the same spot, then they are coterminal angles. And I can call this one beta or whatever you want to call it. It doesn't really matter as long as it's not another alpha because they're not the same angle measurement. Okay? All right, so we're going to look at these examples, but I'm going to have to stop here because I am probably hitting my limit on YouTube. Okay? All right, so I'm going to stop it, start up with the next one. See you in a minute.